Good morning. Excellent. Welcome. Excitement. Yes. High availability is fantastic, and we're here to talk to you about it. My name is Corey Sanders. I'm from the Windows Azure team. I'm co-presenting here with Luis Vargas and Sanjay Mishra. And the way we're going to work this is I'm going to tell you a little bit about Windows Azure, some of the overview, and then we're going to head into some deeper conversation about SQL Server on Windows Azure, and then talk about some customer stories. And so without further ado, let me go ahead and dig in. The one thing I want to start with, we gave a very similar session yesterday afternoon. Did anyone attend that session yesterday afternoon? Okay, if you attended that session yesterday, by very similar, I mean the exact same session with the exact same slides. So if you found it interesting and you want to hear more about it in the exact same way, please stay. But if you don't, then maybe this isn't the right session for you. And sorry about that. Cool, okay. So like I said, what we're going to do is we're going to do some Windows Azure overview. I'm going to spend some time talking to you about sort of how it works, how things are working underneath, and some of the details about SQL Server running on top of it. And then we're going to get into a little bit more deep dive into HA and DR running on Windows Azure, and then some customer deployments. The one thing I will say, the focus here today is SQL Server running on Windows Azure Infrastructure as a Service. Right, so we're not talking today about SQL databases or what was previously known as SQL Azure, the platform as a service offering that we have there. We're focusing specifically on running inside of VM. And the key point there is, if you're running with SQL Server and you want 100% on-premise compatibility, this is the session and the conversation for you to have, right? SQL databases is great in that you don't have to manage the database like you would for an on-premise solution, but it doesn't have that 100% compatibility. And so we're not going to spend too much time on it. We're just going to focus on the SQL Server today. Great. And so let me just charge in here. So when you look at Windows Azure and SQL Server playing together, it adds a lot of value on both sides of the house. First of all, one of the big things that we've really pushed hard in Windows Azure is to make sure that workload mobility really lights up in both on-prem and the cloud, right? And so we've been calling this Cloud OS workload mobility, the ability to take SQL Server, deploy the same thing that you would on premises, and deploy it in the public cloud in Windows Azure, and be able to move those things back and forth. Likewise, starting something in Windows Azure, maybe spinning up some dev test in there, something production, moving something on premise, and then, of course, the hybrid story, which means you really want these machines to feel and look and act the same. And that's been really a big goal of ours. And so we do this, of course, with SQL Server. We also focus on this with BizTalk Server and SharePoint, which, of course, both use SQL Server underneath. The power that Windows Azure brings to SQL Server in this scenario is usage-based and very flexible, automated, and, of course, that hybrid story. And so when you look at why would I spin up SQL Server in Windows Azure when I have an on-prem environment? Well, there's a few reasons. One, it's amazingly fast to go get that hardware and play with it, right? So whether you're using it for dev test, for something quick that you're going to spin up and delete, or whether you're using it for production workloads, which you'll hear about from our customer stories, right? Either way, the ability to do this quickly and flexible is a real value add that you get from the cloud. The hybrid story is great in that it allows you to get these DR scenarios that you normally wouldn't be able to get. Obviously, our data center isn't sitting in your data center, and so you have this story of, look, I have two data centers now with my data, and I have this failover story that Luis is going to spend some time talking about. That's where the hybrid concept for SQL Server really lights up, right? I mean, we talk a lot about hybrid, how it's great, but why do you care about hybrid? Well, for SQL Server, it's because now you have two locations very far away that have this data being replicated, but you're treating them like they're all connected. And that's why that hybrid story really comes in. And you'll see some more about automated as well. We've really focused in Windows Azure on making sure that PowerShell experience is great, right? We want to make sure that it's really easy to spin up using PowerShell and then to manage using PowerShell, just like you would on premises. And so that's a big part of the story, in addition, of course, just the ease of the portal and so on to make that really easy. And so these are kind of the reasons why you may say, look, I love SQL Server. Why do I care about Windows Azure? These are some of the reasons. And so when you look at Windows Azure principles, like I mentioned, the big ones, of course, economics and usage base. We made some announcements this week that make this even better. Of course, for pay for what you use, now when you actually stop these virtual machines, you're not paying for them anymore. That's a big change that we've made in the last couple days, actually. We made that on Monday. And so from now on, when you stop them, if you're using them for dev test or even for production, if you want to turn them off for a little while but without having to go rebuild them later, you don't have to pay in the meantime. We also introduced pay by the minute. Now, what's exciting for this room specifically, is we have a whole bunch of 7 or 8, and we're going to keep adding more and more of SQL Server images available through the portal. And these are per hour offers, right? So we have a pricing model for SQL Server per hour, but now you end up actually only paying per minute. And so there's no automatic scale up to the full hour. We don't round anything. You pay for exactly what you use, even for the SQL Server per hour and the Windows, of course, per hour as well, pricing. And then the last big thing that we announced here for the economics part this week is the big changes for MSDN. How many people have activated their MSDN account on Windows Azure? How many people are MSDN users in the room? Great. And then very few raise their hand for activating. The amount that you're getting from MSDN, I spent some time on, it is a screaming deal, and it's already a part of what you're getting with MSDN. There's no additional purchase you need to make. I would highly recommend going and spending some time on that. Like I mentioned before, for automated and elastic, PowerShell automation is very strong. We do have cross-platform automation. So if you're interested in managing from a Linux box or from an Apple, maybe, then we do have cross-platform capabilities as well, and we do offer the Node.js scripting that sits on top of Windows Azure, and so that allows that automation to happen from whatever you may use. We allow really easy scale up and scale out. And so I'll show you a little bit on the portal, but you can grow these instance sizes very quickly. You can shrink them very quickly. And again, you come back to that economics point, how easy it is to go add VMs and also change the size of them almost instantaneously. And then, like I mentioned, for hybrid, we also have the high availability offer, which I'll spend some time on, where you end up not having to care about the hardware. Right? Let us take care of that. Let us take care of the single points of failure on the hardware. You just need to tell us these guys should be kept up, and we'll take care of the rest. And I'll explain how we do that later. Excellent. So let me get into a little bit more detail. For the IT Pro experience, we really think about this from 3 big aspects. The management portal, to make it really easy and visually appealing to go manage your system. Scripting, like I've mentioned, PowerShell, cross-platform, make it really easy to automate this. And then, of course, we have the REST API underneath. And this allows you, if you want, to go write your entire experience on top of it. So both the PowerShell, the Node.js scripts, and the portal all build on top of that public REST API. So you could rebuild your own PowerShell commandlets if you wanted to. You could rebuild what the portal has, and it would all be there. There's no internal APIs that are used, and that's a big part of our promise, is that we really focus on that REST API is the common layer. The other big thing we've really focused on in Windows Azure is to make sure that we have key server applications available, both validated and images available in the gallery. And so all the bolded underlined ones have images available in our gallery, but everything in this list has been validated and supported by those owning teams. Right? So this is the real interesting value proposition that we do give. For SharePoint, the SharePoint team has validated, and the SharePoint support team will take the calls. For SQL, obviously the SQL team is validated, and their support team takes the calls. And so it's this fluid experience where you call in and say, this isn't working on Windows Azure. We own the whole stack, and so we do the whole support. It's a very exciting and easy way to go deploy your solution. And then, of course, the additional ones, which we're not going to spend time on today, BizTalk Server, Dynamics, Forefront Identity Manager, Project Server, System Center, and, of course, TFS. OK. And we had a session specifically focusing on SharePoint earlier in the week. You can get it, MDC B213, if you're interested. OK, let me just quickly show you what the portal looks like. How many people have used the Windows Azure portal? OK, great. It's worth me spending just a minute on. OK, so here's the portal. This is most recently updated this week. And so just to quickly show you a few things, here on the left side, we end up having all of the different options for compute and application deployment that you can use. And so if you're just on the portal and you want to spin up something new, very easy. You go to the New button. It's not the Start button. It's gone. I was just as sad about that. OK, let's see here. Gallery. And so here you can see, like I mentioned before, platform images. You can see the whole list of platform images that we do offer. So we have a couple Windows ones that you can see we have a plethora of SQL images. And the BizTalk images over here on the right. And SharePoint. And then, of course, we do have the platform partner-provided Linux images. And so this is a big part of our story as well. We want to make sure we support the whole list of possibilities that you may have. And so here you can see we have OpenSUSE, SLES, and then a few different versions of Ubuntu, and then CentOS offered by a partner of ours called OpenLogic. And so the combination of these gives you sort of the full experience. And we're going to keep growing out this list. But let me actually start and show you with SQL. Let me go SQL Server 2012 Enterprise running on Windows Server 2012. So all the latest and greatest. Let me just do this SQL machine. Pick the name. Here's the size, and this is what I was talking about before. You can see we have a whole set of sizes available. Right, so if you're just playing around, you may want to do a small. If you're actually trying to run some production workload, you probably want a little bit bigger. The sizes A6 and A7, while not maybe the most clever names, we did come up with working very closely with the SQL team over what the ratio of memory to core should really be. Right, so the old sizes had a little bit lower memory to core ratio. We sat down with the SQL team and they said this is unacceptable and said you need sizes with a higher ratio, and so the new ones are 7:1 to try and really take advantage of that full power of SQL and the licensing that comes with SQL, which is by the core, right? And so this is why these sizes, the 7:1 sizes came out, is really to make sure SQL ran screaming fast here. So let me just go small here since I'm just doing this as an example. Of course, pick your password and so on. Okay. Now the DNS name, this is the exposed name for these VMs. You can obviously shut this down and make no exposed endpoint if you want to, and just have it talk via your hybrid connection. But this is, if you do decide you want to expose it externally, we sort of build in this DNS exposure to it. So let me just say, Corey SQL demo, see if that's taken. Great. And I'm going to pick a storage account that I have here. And I'll show you that later. Okay. And then, like I mentioned here, with Remote PowerShell, we actually enable it by default. Now, this is secure. It's a terrible circle. Now, it is secure, right? So you end up having to use username and password. And you can also get the certificate down to make sure that you're not susceptible to man-in-the-middle attacks, which PowerShell gives that sort of protection in place. And so we leverage that as part of this. But it is on by default. It makes it very easy if you're like, oh, let me go back and manage this. You don't even have to log onto the box. It's already there and ready for you to go. Okay, and so we'll spin that up. The one other thing I wanted to show you while that's going is, like I mentioned, we have these partners that have given us these images. But one of the other exciting things is a product that we've recently released called VM Depot. And so you can see here, let me just click Browse VM Depot. And so these are actually products that aren't released by those accredited partners. These are just an open gallery for people to go submit their content for open source releases. And so you can see here this very long, extensive list of different products that are available for, here's Drupal. We have some different Drupal boxes and so on. So if you're a big open source guy, this is a great opportunity for you to go try some things out that other people have released and spend some time on it. Obviously, you have the publisher here. So, Bitnami, very, very credible publisher. So you can sort of trust what they've given and play with it and spend some time on it. And so GitLab, whole bunch of interesting, Joomla, LAMP, etc. So this is kind of, the open source playground. If you're interested, is that VM Depot solution. And you can find it here through the portal or through their site as well, the VM Depot site. Okay, great. Let me actually go back to the slides and charge forward. Okay. One of the exciting things that we do have with the Windows Azure Stack, specifically when you're building infrastructure as a service, is the very easy storage manageability and mobility. And so the key thing with Windows Azure, we are just built on Windows Server 2012. So our host is Windows Server 2012, and our hypervisor is the stock Windows Server 2012. So VHDs run just like they run on premises. So the power of this is that with the storage accounts that we make available, you can take your VHDs and move them all around. Now, obviously, licensing, you need to make sure you have the licenses in both places and so on. But the power of this is really sort of mind-blowing. You start things in the cloud, you move them on premises. You start things on premises, you move them into the cloud. And that SQL license you have to manage, but it makes it really easy to go do this playing in both places. And that is because that base is the Windows Server 2012 OS and hypervisor. The other nice thing about the storage solution that we have is it's very highly durable. So everything that's happening on these disks, so I just started up a virtual machine that's got an OS disk attached to it. And if you're familiar with Hyper-V, you may think to yourself, great, so that's a VHD that's running somewhere on that box that these things are booting from. Not entirely. It's actually a VHD that's in Windows Azure Storage, and triplicate copied. So there's no local VHD that's running this thing. It is all off-box in Windows Azure Storage, and there are 3 copies of it. So the reads and writes are going off to storage, and you have highly durable. And so what this means is that physical box dies, the disk is fine. It's running in Windows Azure Storage. The triplicate copies mean any of those disks in Windows Azure Storage dies, the data is OK, because we then go replicate it and repair and recover. Right? So this gives you that high durability. Yeah, go ahead. It's VHD, right? And the question was, is it VHD or VHDX? The answer is it's VHD. The main reason for that is it's a timing thing. We ended up shipping before the original infrastructure as a service solution before Windows Server 2012 was out, and so we just haven't shifted yet. But it's in our plans, absolutely, absolutely. So today it's VHD. Yeah, it's a great question. So that's the key thing there. And so you have this access to these disks in your storage account that are just running your OS and your data, and they're triplicate copies, and you have complete control over them. And let me actually show you what I mean by complete control here. Sorry, can you ask again? So the question is, are they protected copies? So the key thing here is because we're doing the replication, they are triplicate, so we end up doing sort of our own version of RAID, right? We end up actually managing this with the Windows Azure Storage Stack. And so we give that durability promise. We don't actually use RAID. We do a little bit more complicated to use all the disks possible in Windows Azure Storage. So there's thousands of disks backing it. And so this is also why we're able to get a high amount of IOPS, because we manage that across multiple disks. So let me just quickly show you. Here in my storage account, you can see SQL, let me zoom in here. Corey's SQL demo. If you remember, this is the VM that I just recently created. And I'm looking at it through Cloud Explorer. This is a third-party tool that allows you to sort of visually explore your Windows Azure Storage account. So you can see it's 127 gig. And let's see here. Here's the update time, 10:31:56. So this is being updated. Let me hit F5, 10:32:19. So these are the writes. This thing's booting as we speak. So what's really powerful about this is because it's all Windows Azure Storage, it really simplifies some of the things you may do. So here's download, bring it on premises, or here's copy. So let me just hit copy, go to my backup folder, let me hit paste. 127 gig disk using Windows Azure Storage is effectively instantaneous. So this is done now. Because it's all Windows Azure Storage underneath, this is copy on write. So I've just backed up my OS disk that's in the middle of booting. Probably not a good idea, but you can do it. You can also do it actually when it's in a stable place. You can do it with all your data disks. 1 terabyte, 127 gig, it's all the same time, instantaneous if it's in the same storage account, because it is that copy on write. So it's a very powerful aspect of the offer here. Great. So given the talk, and the focus of the talk is high availability and DR, which we'll spend most of the second half talking about, it's worth spending a few minutes describing how Windows Azure manages this, and then how SQL will be built on top of that. So the big aspect of this, as you may be familiar, this is a picture of a rack. It's actually an older version of our racks, but it's a great picture. It shows you sort of the physical machines, and each one of these physical machines are a single point of failure. These boxes can go down at any time. Additionally, for a given rack, we have a power unit, and we have a top-of-rack switch. This is an example of actually the top-of-rack switch. You can see all the plugs going into it. It then feathers out all of those connections out across the rest of the system. And these are also single points of failure. So if we lost this guy, connectivity to all the racks goes down. The whole rack, not all the racks, excuse me, just this rack. Very important. And so this means you're somewhat susceptible to physical failures, just like you would be on premises. And anyone who's sort of running a data center on premises knows this problem. So how do we solve for it? Well, we know this problem, and we built software around it. So we have tons and tons of these racks. And so when you deploy and you say, look, I've got 2 VMs. Let's say they're running database mirroring. Let's say they're running always on. And I put them into an availability set. What that means to us, when you say these 2 should be in the same availability set, we now say, uh-oh, we better manage this for you. And so we know where the racks start and stop. We know which machines are in each rack, and we know which machines are healthy and which machines aren't. So we'll go and put you out there to make sure that you're on different racks. And so you can see VM1 is on the first rack, and VM2 is on the third rack here. And so this means now physical machines, top-of-rack switches, and power units are no longer points of failure for you because you have that replicated copy for SQL Server or even for front ends. Right? And so this, when you combine this for your front end, and this may not make as much sense for SQL Server, but if you're building IIS on top of SQL Server or any product on top of SQL Server, then you combine this with a load balancer, and you have high availability across all of your application. And so in this case, if the third machine dies, goes down, traffic stops, the platform recognizes it, redirects traffic, and then determines how to recover. So actually the platform will automatically recover in this situation and move the virtual machines on rack 3 over to rack 2 or another rack based on what's available and based on what's possible, as fast as possible to make sure that, if the odds are not in your favor, that rack 1 now goes down 2 hours later, we've already recovered, right? And so typically that doesn't happen. The rack failures are actually pretty rare, but they do happen. And so this is why we built the system around that possibility of failure. And that's how we get high availability at the infrastructure layer. They'll spend some time talking about how you then build on top of that with the SQL amazing features and capabilities that SQL has. This is the availability that we offer then with that level of infrastructure. And so when you are spanned across these multiple racks, we're able to promise 395 availability because the hardware fails and you're still up, right? Even if we're doing planned maintenance of any kind, we do it based on these rules that I've outlined. And so we won't ever take down more than one in an availability set, even if it's planned or unplanned. You just get that promise, and that's how that availability SLA gets lit up. Yeah, go ahead. So the question was, how many copies of one VM do we keep? So this is actually what you deploy. So you say one VM, VM1 and VM2, and you'll say these should be an availability set, and then we manage the separation across racks. You could do 3, you could do 4 across availability sets, and then we try and expand it across as many racks as we can. The question is, if you only have one VM, if that goes down, are you done? So the key point here is that if you have one VM, you are susceptible to those single points of failure, but we still care a lot about your uptime. And so when we detect failures, we quickly move you to another machine. And because your disks are in Windows Azure Storage, we just reboot from those disks, right? And so you end up getting a pretty quick failover, but you will see failures in that case because hardware does go down. And so that's why you do it this way. Correct. The Windows Azure Storage is always there. That's right. Great question. Okay. We have a session specifically focused on DR as well, if you're interested. Okay. For Windows Azure. This is the session focused on SQL DR. Okay. Let me just spend a couple more minutes on advanced hybrid networking, and then we'll pass it on here. So, the big things with hybrid connectivity is there's 2 big aspects of this. One that's called site-to-site, which is the ability to take your entire corporate network and connect it into Windows Azure and be able to sort of expose those machines across that hybrid connectivity. And so you could do this with a hardware VPN or with software, right? And so Windows Server 2012, you can connect this. It creates a VPN IPsec tunnel, very secure. All those machines in your data center can now see all the machines that you've deployed in Windows Azure. And the way that this works is when you deploy in Windows Azure, you can actually specify the IP ranges that you want these machines to deploy into, so that you know that they're not going to conflict with IP ranges you've got on premises. And so we virtualize that entire network to make sure that every customer in the world could say the same range if they wanted to, right? And that's a key part of what this offers, is that virtualized network so that you can then make it align with what your corporate network looks like. And we've recently announced some advancements here. Originally, we had just Cisco and Juniper. We've added Citrix, F5, WatchGuard, and of course the software version in Windows Server 2012 for that VPN device. So all of these should be supported and should work for your connection for site-to-site. The other thing that we've recently announced is point-to-site. Now here's what's a little bit different. Site-to-site, again, is all of your machines on premises can see all the machines you've deployed in Windows Azure. But maybe you don't want that level of connectivity. Maybe you're using it for dev tests, and you want a little bit smaller scoped connectivity. In this case, we have what's called point-to-site, which just uses that local box of that developer or that tester, and then only they can see the machines in Windows Azure. But you don't have the hubbub of dealing with your entire corporate site having connectivity. It effectively just leverages some minor routing changes on that box when you connect using the software VPN device on any client machine, right? And so it allows very easy connectivity, still secure, still IPsec protected, but it is only that single box and not the entire site that's connected. So it allows a little bit more control there. You could also do it for machines, individual machines, inside your corporate firewall, again, without having to deal with all of the machines being able to connect. So very powerful. This was just released a couple weeks ago. It's very, very powerful for you to use for these sorts of smaller connectivity solutions. And then the last thing just to talk about, IaaS, PaaS, and agility. So one of the things I'm not going to spend time on is the combination of IaaS and PaaS. So we have a lot of solutions in the portal. You saw a bunch of them. But a great example, if you actually are using SQL databases for something, you can imagine a world where you've got some application up front, some parts of it using SQL Server in a virtual machine, some parts using SQL databases. All of it's going to be in the same data center. All of it's going to be connected in the same way, billed in the same way, and viewed in the same portal. And so this is one of the things we're really excited about. This is all just connected, right? And we're going to continue to grow all of the capabilities in all directions. And so it makes the same one experience for everything you may want to do in the cloud. And then the big additions that we already announced, the pay by the minute, which of course just means we don't round up. It's every minute you pay for. Very complicated animation to show that, but you get the point. Take that away, and then we're good. Okay. The last big thing that I wanted to mention is MSDN usage. So this is a really exciting change that we have as well. MSDN products can now be used in virtual machines. So if you're an MSDN user and you've downloaded whatever ISOs or whatever images that you may want from that gallery, you can now run them in Windows Azure. That's a big licensing change that we announced. We also announced this monetary credit. So based on what type of MSDN user you are, you have a certain amount of dollars that you just get to use. But on top of that, for dev test usage, whether you're using those dollars or more, the actual price rates are lower for an MSDN user. And so this is what's really astounding here. You look at the price rates. If you're running a SQL Enterprise solution today, per hour, that's $2.19. If you're using it through an MSDN account, it's 6 cents an hour. And so those $50 or that $150 goes a real long way for deploying something like SQL Server in a VM for dev test purposes. It's just amazing how powerful that is, and I'd highly recommend if you're an MSDN user, go activate, play with it. Okay, I think with that, I'd like to hand it over to my colleague, Luis, and he's going to spend some time focusing a little bit more on the actual aspects of HA within SQL.
Hello. Thank you, Corey. Okay, so Corey gave us a very good overview of Windows Azure, what the platform provides. So hopefully that sets the good background for what I'm going to describe now. So I'm Luis Vargas. I'm from the SQL Server product team. I work in the high availability area. So let's drill down now into how do we ensure high availability and disaster recovery for SQL Server when running in Windows Azure VMs. So we're going to start talking about these scenarios, why it's important, how do we do it, show you some demos of this, and then we're going to drill down into a lot of details. So some of these may go a little bit too technical. So if you have any questions at some point, please just raise your hand and we'll solve them as they come. So the three scenarios that I'm going to talk about are how to ensure high availability for a SQL Server that is running in a Windows Azure VM. What we do here is protect the SQL Server from any issues that impact either the VM or the SQL Server service itself. And the way we do this is by having one or more replicas of that SQL Server running in the same Windows Azure data center. The second scenario that we'll talk about is how to ensure disaster recovery for your on-premise SQL server, right? The SQL servers that are running in your organization, so that in case that there is a failure in those SQL servers, or there is something that makes them become unavailable, you can basically fail over into Windows Azure, have a copy running in Windows Azure that you can use to continue running your applications. And finally, the third scenario that we'll talk about is once you have your SQL Server running in a Windows Azure VM, in case there is a disaster that impacts that Windows Azure data center, what can you do to expedite bringing another SQL Server in another data center so that you can continue running as fast as possible. And we'll talk about what the platform provides and something else that you can do from the SQL Server perspective in case you want to go one step further. So let's talk about the first scenario, high availability for SQL Server and Windows Azure VMs. So why do you want to do this? As Corey mentions, Windows Azure itself provides already some high availability for your VMs, right? So that in case that the host that is maintaining those VMs fails, that VM is restarted in a different host, right? So there are a couple of reasons why you want to have a SQL Server specific high availability technology in place. One of them is the Windows Azure failure detection works at the VM level. So if something is causing SQL Server to be down, for example, the SQL Server service crashes, or you are continuously running out of memory, those situations are not going to be detected by Windows Azure, which doesn't have any insight into the VM itself. So you may want to have something at the SQL Server layer that detects those type of failures. The other thing is you still own servicing your guest OS, so you still need to patch Windows in those VMs. And doing this takes some downtime, right? You need to restart the VM, and that may impact your SQL Server service. Also, you may need to patch SQL Server itself. So we have service packs coming every 6 months or so, and that will also bring some downtime to SQL Server. The other thing is the service healing. This is the process that Corey described for basically restarting the VM in a different host in case there is a failure. That takes around 12 minutes, right? So if you want to basically avoid that downtime, you want to have SQL Server technology in place. Finally, Windows Azure has some upgrades, right? So from time to time, the platform needs to be upgraded, and that involves upgrading the host machines as well. So this takes around 15 minutes. So when you upgrade the host, those VMs are restarted in the same host, and that accounts for around 15 minutes of unavailability. So these are reasons why you may want to have SQL Server technology in place, right? The same way as we had on-premise today. So what do you do? So the way this works is, imagine you have SQL Server running in a VM, right? What you can do is configure a SQL Server high availability technology where you can configure a secondary, right? You have one replica, so that in case that this SQL Server or this VM becomes unavailable, you can fail over to another SQL Server in a different VM. You can continue running then. Once this VM comes back online, this one becomes a secondary for the new primary, and it starts resynchronizing transactions from the new primary, so that at that point you have high availability for the new primary. Yes? In the next slide, I'll show you the technologies that you can use. So these are the technologies that you can use to configure this. You're probably familiar with this. Anybody familiar with Always On already? SQL Server Always On? Okay, large majority. Database mirroring? Yeah, okay. So same technologies that you use on-premise today, you can use in Windows Azure, right? Now, basically, you configure this across SQL servers running in VMs. In terms of what are the features that you can ensure to these technologies, the first one is zero data loss. This basically means if there is a failure, we'll guarantee that you don't lose any data after you fail over to a new primary. In terms of what is the scope of what is protected by these technologies, with availability groups in Always On, you can protect multiple databases. So if your application depends on 2 or 3 databases, you put them in the same availability group so that if there is a failure, the availability group fails over together. Yes? Is there any plan to remove database mirroring in SQL 14? No, not in SQL 14 now. So, the question is, are we removing database mirroring in SQL 14? The answer is no. It has been announced in the deprecation path, and that means that it'll still be around for 2 more releases. Right? In terms of number of secondaries, availability groups provides up to 4 today in SQL Server 2012. We're actually increasing the number to 8 in SQL Server 14. Both of them, database mirroring and availability groups, provide automatic failover. You're probably familiar with this. You need to configure what is called a witness, right? In the case of database mirroring. In the case of availability groups, you just need to create a witness in the Windows cluster that is supporting the availability group. About using those secondaries for something else and just waiting for a failover. So Many customers want to use these secondaries, for example, for reporting workloads. They want to run some read workloads, or they want to run BI applications on them. This is possible with both availability groups and database mirroring. However, with database mirroring, you probably know that you need to go and create and maintain database snapshots. Right? So you have to create these snapshots from time to time, and then you need to direct those applications to the snapshot. So you have some maintenance that you have to do. In the case of availability groups, this is natively done. So all you have to do is configure those secondaries as readable, and by doing that, your applications can connect directly to those databases in those replicas and read from them. Okay. Yes, so the question is availability groups in which edition is available is only in enterprise. Right? Database mirroring is available in standard enterprise at this point. Yes? Let me go back. The question was, do we also allow asynchronous availability groups? Yes. So actually, both of these technologies support synchronous and asynchronous modes. Basically, synchronous means block the transactions on the primary until you get an acknowledgement back from the secondary that it has stored successfully. But they also support asynchronous, in which case we don't wait, and we just commit the transaction and eventually send the transaction to the secondaries. In this case, because we're talking about high availability within Windows Azure, and we want to ensure that there isn't data loss, I'm talking about specifically the synchronous mode. Right? When we talk about disaster recovery, we'll talk about the asynchronous mode. Right. So the question is, so we can take it offline. There was a question about performance using synchronous mode with always on. So that will depend on workload and the latency and the size of the VMs. So we can talk that offline. So let's move on to the next slide. So in terms of why would you want to use availability groups, there are another reasons why we're recommending customers to try availability groups. Things like flexible failover policies. So you can specify for your availability group the different situations that will cause an automatic failover to happen. And this can be things like the SQL Server service is down, to things like the SQL Server service is not responding within a particular amount of time, or you have a continuous out-of-memory exception, and things even like there are unresolved deadlocks, for example. So you can really specify many different levels of how sensitive you want your SQL Server to be to these failures and move to a different server. Things like backups and secondaries. You can use your secondaries to take backups. So you know backups are generally IO-intensive operations. You can start moving those into the secondaries. Improve manageability. We have very good graphical tools that show what is the status of your deployment, and I'll show you that in the demo. Support for other features within SQL Server, so you can add file stream data, file table data into your availability group. Some considerations to have if you use availability groups. Availability groups require Windows cluster, right? So if you want to set up an availability group, you need to set up a Windows cluster. Now the consideration is, this is not a traditional Windows cluster that we had in the past, where you have to configure shared storage. Availability groups do not require shared storage. This means all you have to do is each of these VMs, each of these machines need to have attached disks, right? Local disks that they can use. And basically, the availability group will replicate the log of the primary to all of those secondaries, right? So all these transactions are available everywhere. And also, availability groups require these VMs to be part of the same Windows domain, right? So on-premise, you very likely have your Windows domain. You have an Active Directory domain controller. In the case of Windows Azure, you will have to configure an Active Directory domain controller and a Windows domain so that you can add these VMs to the same domain. Right? Things to consider. Anybody familiar with listeners? Availability group listeners? Some people? OK. So listeners is this concept of a DNS name, a virtual name, that applications can use to connect to the primary, irrespective of how many replicas you have in the system, right? So before with mirroring, what we had is something called failover partner. In your connection string, you will specify 2 replicas, one primary and one secondary. And then the connection string will try both of them, and it will find the primary. We introduced listeners with availability groups so that with a single name, we can find the primary, even if you have 4 or 5 replicas. That is not supported as of today yet in Windows Azure. We're working hard to have it in the next couple of months. Right? And the reason is basically that this requires something called a floating IP. So we need an IP address that can move across different machines. We're working on this. It's going to come in the next couple of months. In the meantime, the recommendation is you can still use failover partner as before with database mirroring. Right? The limitation, obviously, is that this will only find the primary out of 2 replicas. So if you fail over to a different replica, the connection stream will not find that. Again, coming in a couple of months. So what do you need to think about when you configure a high availability technology in Windows Azure, either database mirroring or availability groups? Well, really what you need to think about is how do you go and provision these VMs to get the most availability from the platform itself? So when you provision these VMs, you need to think about 3 concepts. These are concepts from Windows Azure. First one, same affinity group. So this means make sure that all of these VMs are part of the same Windows Azure cluster, right? And this is basically to reduce latency between primary and secondary. This is something that could have an impact, for example, on synchronous mode, right? So if you want to reduce latency, make sure that primary and secondary are part of the same affinity group. Second thing, what Corey mentioned before, availability set. Make sure that the VMs are in the same availability set, and this will put these VMs, primary and secondary, in different fault domains, different racks, right? And also in different upgrade domains. Upgrade domains means when Windows Azure does an upgrade, right, every month or so, it will ensure that it only upgrades one of these VMs at the same time. It will not go and upgrade these 2 VMs at the same time. So you will always have at least 1 replica running. And the final thing is make sure that you put these VMs as part of the same virtual network, the same VNet, right? And I'll show you this in the demo. By putting this in the same VNet, this will ensure that the IP addresses of those VMs doesn't change, even if those VMs are restarted in a different host, right? So if you don't put these VMs in a VNet and these VMs are restarted in a different host, the IP address will change. And then in the DNS layer, there'll have to be an update, right? Mapping the name of the VM to the new IP. That remapping can take up to 12 minutes. So those are 12 minutes that your applications will not be able to connect to the new name, to the new IP. So by putting this in the same VNet, you avoid these changes. And then even if the VM is restarted, immediately you can connect to the name. And this is also a requirement for setting Active Directory. So if you use Windows authentication, for example, to authenticate your users to SQL Server, you need to establish an Active Directory domain controller. I'll probably don't go a lot of detail here. The consideration here is, how many people have created Windows clusters before? Some people, okay. So when you create a Windows cluster will ask Active Directory from an IP address for something called the cluster network name. So the cluster network name is a name that you can use to configure the cluster and connect directly to it. So that requires an IP address itself. Today in Windows Azure, we have maximum 1 IP address per VM. So if you try to create a Windows cluster by going into the Windows Cluster Management UI, that creation will fail when trying to get that IP address for the cluster network name. So in order to work around this, I mean, obviously, we're trying to work on this as soon as possible. But what we have done is we're providing a PowerShell script, right, that basically allows you to create the Windows cluster in Windows Azure without going through the process of getting the IP address for the cluster network name. So the takeaway here is, if you go into the link here, you'll find this in the Windows Azure page. You can download the script. You can just run this create Azure cluster PowerShell script, and it will create the cluster successfully in Windows Azure. So don't go and try it through the UI today. You can use this PowerShell script from now. Once you have created the cluster, now the configuration is exactly the same as what you do on-premise. So this is the only difference. Once you create the cluster, you can go and configure the availability group in the same way as we do it today. I won't go into detail here. I'll show you better the deployment in the demo. But we have PowerShell scripts, and we have graphic UI tutorials that show you with a lot of screens. We have like 30 screens how to do all of this. Now, if you use database mirroring, right, so you're used to database mirroring, the only consideration to have is if you want to use Windows authentication, remember you'll have to set up the Windows Active Directory domain controller. After that, the configuration is the same as on-premise. So let's go into the demo. So I have the Windows Azure portal here. I'm going to be using some VMs that I have configured in advance. So I'm going to be using Contoso DC1, Contoso SQL 1A, and Contoso SQL 1B. So these are my 3 VMs that I'll be using in this case. The first one is my domain controller. So let me look at it. The main thing that I want to show you is how these VMs are configured. So if you look into configure here, oops, let me, okay. This is a medium VM. The first thing that you'll see is the availability set concept. Right? This is what ensures that these VMs are in different racks and in different upgrade domains. And I have located my 3 VMs in the same availability set. I have located the domain controller, SQL 1A, which is going to be my primary, and SQL 1B, which is going to be my secondary. And the other thing that you can see here is that I have located this in the same virtual network as well. Right? Remember, this is to avoid changing the IP addresses of those VMs. So if I go into my domain controller, you'll see that this is the same. I lose some connectivity here, so hopefully it will come back soon. But I wanted to show you how the computers, let's see, it seems like we lost some connectivity. Let's see if this works. I wanted to show you the computers and the users. Well, it seems we're running into some connectivity issues. Let's try again. Sorry about that. Let's see if this works. Okay, this seems to be connected, so hopefully it'll come back very, very soon. Okay. So the other thing that I can show you in the meantime is, see. Okay, so we're back here. Sorry about that. Okay, finally we're back. So I want to show you the domain controller here. The first thing is you can see the computers that I have. These are the computer objects in Active Directory, similar to what you have on premise. So we have 3 computer objects. We have 1 for the cluster. So when you set up the cluster, it will create a computer object in Active Directory. And then we have the primary and the secondary SQL servers. Now, the other thing that you will see are the users. So in this case, for this demo, all I have created are 2 users, 1 for each of the SQL Server services. So each of these SQL servers are running with their own SQL Server user account in Active Directory. So now we can go into the primary SQL Server. So let's look at how this looks. So we have 1 availability group, right? So I created an availability group. It has 2 replicas. I have the primary that I'm currently connected to, and it has a secondary. I'm protecting 3 databases. Right, so that in case that the VM becomes unavailable or SQL Server becomes unavailable, the availability group will fail over to the secondary replica. You can see how these replicas are configured here. You can see that they're configured for synchronous commit, right? This to ensure data loss. They're configured for automatic failover, right? And you can see that they are synchronized, right? So the secondary is up to date to the primary. Now, what you can do is, for example, stop the SQL Server service, right? Just to simulate that there is a failure in SQL Server, so we can stop this one. I'm just going to say yes. And then what will happen is SQL Server will stop. The availability group will detect that SQL Server is down and then fail over to the secondary. So you can see now that I connect to the secondary, SQL I1B, that now it has taken the role of primary, right? So it takes around 5 to 6 seconds from the time that the failure is detected to the time that the new primary takes place. So your applications can reconnect after around 6 to 7 seconds, and they can continue running, right? So instead of waiting, for example, for Windows Azure to restart that VM in a different place, which may take around 15 minutes, it will take 5 to 6 seconds. So I think we're losing connectivity again, so let's go back to the demo. Sorry, not to the demo, to the presentation, and then we'll look back at the demo. All right, the next scenario that I wanted to talk about is ensuring disaster recovery for your on-premise databases. So many of you may want to have multiple copies of your database running in different places in case something impacts those databases. And we have seen many cases from customers where some of these things are not really dramatic. Some of these things are just like gateway failures, for example, some things that impact connectivity to their deployments. Some cases are more dramatic, like in the case of New York, for example, we saw flooding impacting those SQL servers. So many customers would like to have some sort of disaster recovery solution so that they can continue running in these cases. However, having a disaster recovery site is expensive because you have to pay rent, you have to maintain hardware, you have to have operations people running the site. So because of this, many customers are not able to have it today. So we're really simplifying this scenario by allowing you to have replicas of your databases running in Windows Azure. So this is what you can do today. So on-premise, you can have your primary SQL server. Likely, you can have a secondary SQL server for high availability. And now you can have one or more replicas of your SQL server running in Windows Azure. Now, once you go and add these replicas in Windows Azure, these replicas will continually synchronize from your primary replicas. So every time there is a transaction on the primary, this will be synchronized to the secondaries in Windows Azure. You can select where do you want to put these replicas. This can be in any of the different data centers that we have in Windows Azure. West US, East US, Asia, Europe, etc. How do you decide where to put them? Well, you decide them based on a couple of dimensions. One is there may be some political considerations. There are countries, for example, that they require them to have the data centers within this particular area. And latency may be another reason. You may want to keep them within a certain latency. Right? So some things to consider where to locate these replicas. Finally, once you go and create these replicas in Windows Azure, this will ensure very low TCO, very low total cost of ownership. Right? So the only thing that you'll have to pay for is the VM, right? The use of the VM, and the storage in Windows Azure. We have many customers that are actually inverting the deployments. So in some cases, they want to have the deployment running in Windows Azure, but they actually want to have a copy running locally. Right? So some customers will actually keep this copy locally just in case. And Sanjay will talk about some of these deployments. So we have actually customers in production today, and he'll talk about some of these examples. In terms of the technologies that you can use, again, you're probably familiar with this, nothing new. You can use availability groups, database mirroring. You can use log chipping if you want to. Now, you can use, in general, the recommendation here is use asynchronous mode. Right? Remember, this is to avoid impacting the performance of the primary, waiting for acknowledgments from the secondary, especially if you have high latency between your site and Windows Azure. And the good thing to consider here is if you use availability groups or snapshots with database mirroring, you can still use those replicas in the cloud for reporting applications or BI, for example. So you can start moving some of these applications in the cloud and run on top of the replicas. Also, additional benefits, if you use availability groups, you're able to take backups from the secondaries. Right? So if you want to have backups outside of your data center so that in case a user deletes a table, for example, and you want to have a backup available, you can have these backups taken from the secondary in the cloud. Right? What do you need to do? So really the main consideration here is you need to establish that connectivity between your on-premise network and Windows Azure. And to do that, what you have to do is to configure what is called a VPN tunnel. Right? There is instructions in Windows Azure. There is a link. Basically, you have to either configure a VPN device on your organization, or you can configure Windows Server remote access. Right? So in Windows 2012, you can actually configure this through software. Once you do that, you can configure your SQL Server technology, availability groups, database mirroring, or log chipping in the same way as you do it on-premise. And again, we have tutorials of how to do this, so I won't go into a lot of detail there, but I'll show you a demo of how this works. So what I have here, this is the configuration that I'll be showing you. On-premise, this is actually running in Redmond in Washington State. We have an availability group, which has two replicas, one primary and one secondary. Right? These are part of the same Windows domain. There is an Active Directory domain controller running there. And we have configured the VPN device in this domain to connect to Windows Azure. Right? So there is a VPN tunnel connecting the two. And in Windows Azure, we have added one replica, right, that is continuously synchronizing from my primary replica. So let's look at the demo. OK. So again, I have another availability group here, right? This is protecting one database. And you can see that I have 3 replicas. I have CSN v441 and CSN v439. So these are the on-premise replicas. And now what you see is that I actually have a third replica here called AG Cloud Replica. So this is a asynchronous replica, right, that is configured in Windows Azure. So we can actually go into the Windows Azure portal and search for that replica. So let me just find it here. OK, let me see if I can find it. OK, I think I don't see the search button. There's a search button somewhere here. Oh, here you go. OK, so AG Cloud Replica. So you can find that we have the VM here. This is the VM that is hosting the replica in the cloud. And we can actually connect to that one. So I can connect to the replica here. And what you see is SQL Server running in that replica in the cloud, right? We can actually use the replica. So we can go and run a query. For example, I have a database here, which is synchronizing from a replica on-premise. It's called DB1, right? And I can select from a table. And you can see that I have some values returning from that table, right? This is all coming from the replica in the cloud. Now I can go into on-premise, right? This is, again, the primary replica. And I can see that I have the same values there, right? So let's wait for this to connect again. And we can run some inserts here. So we can insert some values on the primary replica, right? I inserted 5 values. And then I can go back to my replica in the cloud, rerun my select statement, and you can see that I have the values returned there as well. So automatically synchronizing your transactions from on-premise to your secondaries in the cloud, right? And you can use now these replicas for your reporting applications, for example. Now, in case that your primary SQL Server becomes unavailable for some reason, all you have to do is go to your cloud replica, in this case, AG Cloud Replica, go to your availability group, right-click, and say failover, right? So after doing a failover, you can failover to this replica in the cloud. And there is a wizard of how that will guide you through the failover process. So I can say, I'm going to failover to this replica. Right, I'm going to say next. Now, given that this is an asynchronous replica, there is a potential of data loss, right? There may be a few transactions that haven't been replicated yet. You can go and find in the dashboard, for example, in that graphical screen that I show you, what is the estimated data loss. So it will tell you what was the last time that that replica committed a transaction, and based on that, you can take a decision of whether or not you want to failover. Assuming that you want to failover, you can say yes, and then finish, and then basically this will go and complete the failover process, at which point you will have a primary running in the cloud, right? So this one becomes now the primary, right? You can see here, this is my new primary, and my applications can continue running connected to this new primary. Any questions so far? OK. So let's go back to the presentation. Now, the final scenario is if you have your SQL Server running in Windows Azure VM, and you want to ensure disaster recovery for that VM in case that there is a disaster that impacts Windows Azure, what can you do? Well, the first thing that you can do is you can just depend on what Windows Azure provides. So the platform itself provides disaster recovery for your VMs. However, there's a few limitations that you need to consider. So if you're using multiple disks, remember in Windows Azure, you can attach many disks to your VM. Each of the disks is 1 terabyte. So if your database is higher than 1 terabyte and you need more disks, you cannot depend on the Windows Azure disaster recovery technology. And the reason is that the geo-replication, basically the synchronization that Windows Azure does from one Windows Azure data center to another, doesn't guarantee ordering across the different disks, right? And in SQL Server, you know that we need this ordering, right? Because we have something called write-ahead logging mechanism, and we always need the log to be in front of the data, right? So we need the log to have all the transactions before they are stored in the data files. So we cannot guarantee this if you have multiple data disks in Windows Azure. So if that is the case, you may want to configure a SQL Server-specific disaster recovery technology. Another reason is the SLA that Windows Azure provides today for disaster recovery, which is around 24 hours to recover your VM in case of a Windows Azure disaster, and potentially up to 30 minutes of data loss, may not be enough for your requirements, right? So you may want to be running in a different data center as soon as possible, and you may want to guarantee less data loss than that. So that's another reason why you may want to configure a SQL Server high availability solution. Finally, you may want to also be able to test and execute your disaster recovery strategy at any point without having to wait for Windows Azure to do it. So the way this works is if you have your SQL Server running in a Windows Azure site, you can configure a SQL Server disaster recovery technology so that you can basically fail over to the different site anytime that you want. Again, we support the technologies that you're familiar with. We support database mirroring. We support backup to URL. Anyone familiar with backup to URL? It's a new technology in SQL. Only a couple of people. OK. So we just released this, SQL Server 2012, SP1. What this allows you to do is take a backup of your database and store it in Windows Azure storage. You can store it in any data center that you want. So by doing this, you can maintain a backup in Windows Azure storage, and then you can take that backup and either restore it on-premise, or you can restore it into a VM in that Windows Azure data center. So this is another technology that you can use to protect you from any disasters. Availability groups, they're not supported yet as of today. We're working on it. It's going to come in the next 2 to 3 months. The reason is we need to allow Windows Azure to define networks that cover multiple data centers. So in order to create availability group across different data centers, we need to be able to add those VMs, right, the primary and the secondary, to the same availability group. So that's coming later this year, sorry. In the meantime, what are the recommendations? If you have a single disk in your VM, you can just take a dependency on what Windows Azure provides. If not, you can either use database mirroring, right, or you can use backup to URL. The other thing that you can do is use availability groups and take a copy of your availability, put the secondary your availability group on premise. Again, there is not really any new magic of how to configure this. All you have to do is, if you want to configure database mirroring, for example, across Azure data centers, is configure a public endpoint for the VM so that those VMs can connect to each other. After that, the configuration is as on-premise. So I'm going to let Sanjay come and talk about customer scenarios.
Thanks, Luis. Thank you, Luis. Any questions so far? Oh, great. How many of you have actually deployed always-on availability groups on-premises? Wonderful. How many of you have played with SQL Server in Windows Azure VMs? Okay. Now let me ask a question where I expect more hands to be raised. How many of you got your Surface Pro and Surface RT? Okay, good. I expect all the hands to be raised for that. All right. If you have deployed always-on availability groups on premises, and you are now trying to deploy the similar thing on Windows Azure, working with customers, what we have learned that a couple of concepts are slightly different. The technology is the same, the functionality is the same, except a couple of concepts are slightly different. And the customers that we worked with for almost a year, we had it in preview. So we worked with several dozen customers in the preview who played with this. And then over 6 weeks now, we have it is in GA. So we have several customers who have played with it, tested with, done proof of concepts, and we have several customers who are already in production. So I'll be talking about you who are either close to production or already in production workloads for customer deployments. So the subtle differences between deploying always-on availability groups on premises and doing that on Azure. One quick thing is, how many of you are clear about what is availability sets and what is availability group? Okay, so it's worth pointing that out. Quite a few customers, we needed to re-emphasize this concept with them. Availability sets is a I'm hearing an echo. Do you hear the same as well? Okay. Availability set is a concept in Windows Azure where multiple VMs are put in different racks. Availability groups is a SQL Server concept where you put multiple SQL Server instances in an availability set so that your database is protected among those SQL Server instances. To achieve high availability of SQL Server in Windows Azure VM, you need both. You need to put those VMs in an availability set, and you need to create availability groups for your SQL Server. So just to clear the concept. Concept number 2 that we had to drive with these customers is for people who are familiar with deploying availability groups on premises, the steps for doing this on Azure there are little differences. So people who followed the documentation that we have for on premises and try to use the same steps for Windows Azure VMs, they had a bit of difficulty. And as Luis pointed out, we have a separate list of steps, documentation, tutorial, and we have also PowerShell scripts provided you. Use those scripts to create your Windows cluster, use those scripts to create your availability groups, and you'll be fine. So those are some things to know beforehand. We'll talk about 4 customers who are in different stages of deploying these technologies. An online travel firm, we'll talk about a leading car manufacturer, we'll talk about a video streaming company, and a healthcare CSV. We picked these customers to give a perspective of different types of applications. These are all serious production applications, and I'm sure you either already have or in next few days will be using services of one or more of these companies. So we are not able to use their names here because we are in different stages of creating a PR agreement with them, to creating a case studies with them, and once that is done, we should be able to publish those case studies with the customer names. What this online travel firm does is it offers various travel and various tours in Europe. And as you can see, they handle over 700,000 customers in 2011. They already have on-premises SQL Server always-on availability group in place, and but they have only one data center. This is what they have today on-premises, but they want to extend it so that they can leverage Azure as a DR data center, and they'll be extending it to do this. So they'll be putting an extra secondary on Azure VMs. And this customer is they have already completed the proof of concepts, and pretty soon they'll be deploying this in production. Question?
What is the max size of database you guys support?
Okay. The question, what is the max size of databases? Let me roll back a bit. How many of you know what is Windows Azure SQL database and what we are talking about here? What we are talking about here is SQL Server running in Windows Azure VM. This is real SQL Server. So, and that has no limit in terms of SQL Server database size. What it limits on how much storage you can attach to the VM and how much database it can handle. We have also called Windows Azure SQL databases, also known as SQL Azure, which has a 150 gig database size limit, and we are not talking about that here. So we are talking about SQL Server running in a VM, and a VM, depending on the size of the VM, you can attach as many disks, and each disk can be 1 terabyte. And for a extra large and A7 size VMs, you can up to 16 disks, each can be 1 terabyte. So you can imagine how big your database can be. And you can provide HA and DR for entire of those databases and multiple of those databases within that 16 terabyte limit. Make sense? Okay, we'll talk about a leading car manufacturer in the world. This customer went live just last week, and what they deployed is an application which is they call it Car Life Portal, where they collect various telemetry about the car, the various driver experience from the car, and they also connect the similar car owners in a social networking manner so that they can exchange information for people to even sell, own, or do whatever to want to do with the car. And they deploy this on Azure, a high availability using Windows Azure VMs with availability groups. It looks like this. and they do not have a DR, they will be pretty soon they'll be deploying a DR as well. A online video streaming company, HA and DR is very important for this company because this is consumer, this is end consumer who is using on a Friday evening when a family is watching video, you don't want a downtime. This customer has done a proof of concept and pretty soon they will be going live on this. And what they have is, they have Azure as their primary, so they'll be using one secondary in the Azure data center as a automatic failover HA, another secondary in their on-premises data center as a DR. This is what it's going to look like. So the cloud will be used as primary, on-premises will be used as DR. And the last example we talk about today is in healthcare. CSV is a cloud service provider. That means they have applications they provide, which their end user customers, they go and hospitals and clinics, they buy then they deploy it. This customer sells the software which customer can deploy in their own data center, and this customer also will be providing services from Azure as a kind of hosted provider. And what they want is that they want a complete 100% lift and shift. Everything that works for the on-premises customer, they should be able to exactly deploy the same thing on Azure. And what also they want is a HIPAA compliant. Anything from the healthcare industry here? Okay, I'm glad that we addressing this here. And they need HIPAA compliance, being in the healthcare industry. And Windows Azure VMs is HIPAA compliant. And therefore, they picked this technology to deploy SQL Server and all other applications in Windows Azure VMs. And that would be the primary would be using on Azure, but their compliance regulations also need that they have a copy of their data on premises, and for which they will deploy a secondary of their data on premises as a DR and for regulatory purposes. This will look very similar to the previous example, just different motivation to have a secondary on premises. That's all about customer examples, and I'm handing over to Luis to wrap it up, and we'll be sticking around for further questions as well.
Quick question. Sure. Those hybrid scenarios you're talking about, are those specific to SQL Server 2014?
Okay.
Are those available today with SQL Server 2012?
Okay. The question is, the hybrid scenarios that we talked today, are they available only for SQL Server 2014 or for SQL Server 2012? They are available for SQL Server 2012. They will be available for SQL Server 2014. You can actually deploy some of the scenarios in the earlier than SQL Server 2012. For example, database mirroring is available in SQL Server 2005, 2008, 2008 R2. So if you want to deploy a hybrid of database mirroring, yes, of course, you can use SQL Server 2008 R2 as well. Does that answer the question? Okay, thank you.
Okay, so let me show you what is coming in SQL 14. So we talk about all those hybrid scenarios. I show you there are some links. You can go and find out how to configure them. However, we want to really simplify the story, right? So we as Microsoft, we own SQL Server and we also own Windows Azure. So we can actually create better hybrid experiences for you. So let me show you what we have coming. So again, going back to my SQL Server, in this case, I have one availability group with 2 replicas on-premise, primary and secondary. Now, let's say that I want to have 1 or more replicas in the cloud. So today, I can go and follow those guides that tell you how to do this manually. But in SQL Server 14, what you will be able to do is say add replica, and this will bring a wizard that will, the same wizard that we have today for adding a replica on-premise, that we have extended to be able to add replicas in Windows Azure. So after I connect here to my primary, what you will see is that we have added a new button here called Add Azure Replica, right? This is a button that will allow me to go and create a replica for my databases in Windows Azure. Now, this screen is very similar to the screens that you have in the Windows Azure portal. So here, SQL is remembering that I have already connected to Windows Azure before, that I use this certificate to connect, and that this is my subscription. If I haven't connected yet to Windows Azure, I can say download the certificate and the subscription from Windows Azure. So this will ask me for my Windows Azure portal, my credentials, and after doing this, it will go and download my certificate and subscription. Once I have that, I can connect to my Windows Azure subscription from SQL Server, right? So when I click connect, SQL Server will download information about my Windows Azure subscription, things like what are the different SQL Server images that I have available, right? SQL Server 2012, SP1, SQL Server 14, etc. What are the sizes of VMs, small, medium, extra large, etc. So in this case, the wizard knows that I'm running in 2012 SP1 Enterprise, so this is the image that it selects by default in the portal. Now I can select what is the size of a VM that I want to use to provision a replica in the cloud. So I can say I want a large or an extra large. I'm going to say a medium in this case. I can give a name to this replica. I can specify my password that I'll use to connect to that replica. We're running out of time, so I'm just going to finish this very soon. And I can specify where do I want to create this replica. So you can see that my network administrator has configured multiple different VPN tunnels to different regions in the world. So I could locate this replica in the US, in Europe, etc. So in this case, I'm going to say, put it in the US. And finally, all I have to do is specify a domain administrator, or so, any user that has privileges to add a VM or a machine into my local domain. So I can specify this. And after that, you'll see that I'll have this replica added to the list of replicas in my availability group. I can select if I want that replica to be readable or not. So by saying yes, that means that replica in the cloud will be readable. And finally, I can specify how do I want to move my data from on-premise into the cloud. So the easiest way is just to select the default option, which is full synchronization. And this basically means take a full backup of the database and restore it into that SQL Server in the cloud. So after I do this, basically the wizard will run. It will do a bunch of validations, and it will go through around 14 steps so that at the end of it, I'll have a replica running in the cloud that is synchronizing from on-premise. So really trying to simplify the experience for customers. So I think with that, we conclude the presentation. There are a bunch of resources, so you can go into the presentation and you can find these resources online. If you have any questions, Sanjay and I will be here, and thank you very much for coming.